Hi everybody, welcome back to ME3005 Laboratory. Today we're going to be doing the curved beam and bending laboratory. So the first thing I want to do is go over the equipment that we'll be using for this particular lab. Obviously the first and most important piece of equipment here is the curved beam that we're going to be using in this lab. So if you have your lab handout and you've taken a look at it, hopefully you've had a chance to look it over. You should have seen the model for the curved beam, and here now it is. It's made out of aluminum. And we're going to look at 7 different strain gauges on this particular curved beam. So we have 2 on the inside of the curve on the curved beam that are single strain gauges. That's on the inside of the curve. And similarly, we have 2 single gauges on the back side of the member here. And finally, we have a strain gauge rosette, which is kind of on off-axis location. That will provide us 3 additional readings in the rosette configuration. So that's the curved beam for this lab. We'll go through the measurements of this beam shortly, but we just wanted to show it to you first so you get an idea of what it looks like. Also for this lab, we'll need strain indicator boxes, similar to what we did with the combined loading lab if you've gone through that one. Here, this is the strain indicator box that we're going to be using. And again, each one of these boxes has 4 channels, 1, 2, 3, 4. And so we'll need 2 boxes for this laboratory to accommodate our 7 gauges that are on this particular member. So we're going to cut now, and we're going to set up some measurements and go through and put this actual member inside the frame. To take measurements of the beam accurately, we had to do a couple of tricks. Since this isn't really an easy thing to measure on its own, we actually took a tracing of the aluminum member on a piece of paper, and that will allow us to more easily measure things like the height of the beam, which here is roughly 2 inches. We'll show some more exact measurements in just a second. And also things like lengths and other critical important dimensions that are laid out in the lab. To measure the thickness, we actually use a caliper that looks something like this. And this caliper will allow us to actually get the thickness of the beam as well. So we'll provide you those numbers in a separate shot. All right, everybody, now by the magic of film and cutting, we have cut to a situation where we've now got our apparatus fully wired up into our strain gauge boxes. So I just quickly want to run through the strain gauges on the apparatus one more time so that we're crystal clear on where the gauges are and which gauge is which. So first, this is the inside edge of the apparatus, and we have 2 strain gauges. We have strain gauge A1 and A2. We call them A1 and A2 because they're on the inside edge there at point A. Then on the back side of that, we have 2 additional gauges as well, which are B1 and B2 at sort of point B on the apparatus. And then finally, we have the strain gauge rosette, which is on the surface of the piece, kind of on the top here, which has 3 different strain gauges, 1, 2, 3. We have one that runs at sort of this tangential direction, which we're calling C1. We have one that runs along the radial direction, here kind of in this direction, which we're calling C2, and then one that runs at a 45 between the 2 of them, which is actually kind of the horizontal one here, which we're calling C3. So those are the 3 gauges that we have in our experiment, and we're going to be applying load on this piece by turning this crank wheel here sort of in a clockwise direction to push this thing downward. So we'll apply a compressive load, and the load here is going to be read out by this load indicator box. You can see the red number here is telling us how much load is being applied on the particular piece at this very moment. So when we turn the wheel, it will apply additional load to the piece, and we're going to turn the wheel such that we apply a known load, and we can use that load then to calculate the stress inside of the piece at those various points, marry them up with the strains, determine things like the elastic modulus and things like that. So here now we've got the piece loaded into the frame, wired properly, everything is zeroed out perfectly. What we're going to do now is we're going to apply 200 pounds of compressive force to this apparatus using our machine here. So we're looking at the load indicator box up here to tell us how much load we've applied to the piece. Right now it's reading -2. It's kind of a approximate 0 value that we have right now. We're going to rotate this wheel clockwise to apply compression on here until this reads -200 pounds of force, which we apply. So I'm going to apply that -200 right now. I'll turn this clockwise slowly until we get to approximately 200. So it's like getting as close as you can without going over. Price is Right style, or anyone that watches The Price is Right. Okay, so there we go, right about negative 200, you know, as close as I can get using this manual wheel. So let's come over and look at the strain gauge readings. So the way that we've set this up, this is strain gauge reading for gauge A1, it's negative 315 microstrain. Gauge A2 is negative 322 microstrain. Gauge B1 is reading positive 183 microstrain. Gauge B2 is reading 182 microstrain. Now we'll come over to the strain gauge rosette. Gauge C1 is reading positive 115 microstrain. Remember, this is the tangential direction. Here, this is gauge C2 reading negative 50. Remember, this is the radial direction. And here, this is gauge C3 reading positive 32. And this is that 45 degree that falls in between the radial and tangential gauge. So we'll take one more measurement now, loading up to negative 400 pounds, so 400 pounds of compression. We'll start from where we were on the previous shot of about negative 200, and we'll put an additional negative 200 to get us to negative 400. So I'm going to turn this clockwise again. Up, 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 up we go to about 400 pounds. So again, this is kind of a manual loading, so it's hard to get the exact value. I'll do the best that I can. So a little bit less, and there we go. So about 400, we'll say 402. So we can come over now to our strain gauges again and look at the readings. A1, negative 641 microstrain. A2, negative 652. B1, positive 373. B2, positive 367. We have C1 reading positive 228. Again, this is the tangential direction. We have C2 reading negative 71. Again, this is the radial direction of the rosette. And then we have C3 reading negative 40, which is the 45 degree rosette between the radial and tangential. So that will conclude